Okay, guys, we have solved expressions, we have translated expressions. Now we're going to put it together and we're going to translate and solve expressions, okay? So starting with translating it, because we have to be able to write the numerical algebraic expression before we can evaluate it. So we have the sum of 16 and x. Now I recommend that you get your notes out from 2 days ago, okay? Where we have all those keywords on there. And I'm going to pull mine out right now just to show you and remind you. It's these right here, okay? The translating expressions notes. We have all these keywords that help us. So I would keep those close by me so that when I am translating, I'm going to get it right. So number one says the sum of 16 and x. Remember, sum means addition. So the sum, 16 plus x, okay? Then I want to come over here, and they said x equals 12. So I'm going to write 16 plus 12, and I get 28, okay? Number two, the quotient of 48 and n. Quotient, if you look at your keywords, means to divide. So the quotient, and remember, this is how we write it in 6th grade, 48 over n. Now, when we do quotient with division, order matters. So if my 48 comes before my n, my 48 needs to be my numerator and my n my denominator. Okay? So when I rewrite it, 48 over 8. 48 divided by 8 is 6. Number 3, 7 subtracted from k. Now remember, that is like a turnaround phrase, they call it. So 7 subtracted from k, okay, subtracted. So what that means is we're going to switch places. So we're going to say k minus 7 because 7 subtracted from k. So then I'm going to write 18 minus 7, and I'm going to get 11. Okay. Number 4, 4 more than 1/3 a. So more than, okay, 4 more than 1/3 of a. So 1/3 of 1/3 a. Ooh, I don't like how they don't have the word of, but that should be 1/3 of a. Okay, so multiplying that. 4 more than. So then add 4. Come on in. Keeping going. So 1/3 a plus 4. So this is like an order of operations kind of problem, and so we have multiplication first, then addition. So multiplication comes first if you have those notes out. So 1/3 of a. So 1/3 of a. I'm going to put that in parentheses times a, which is 15 plus 4. Now, like I said in class, when I have 1 as a numerator of a fraction like this, it would be the same thing as saying 15 divided by 3, which is 5. So we'll do arrow. So now I have 5 plus 4, and we get 9. Okay? The difference of twice r and 5. So difference means subtract, and we're going to do twice r. Remember, twice means times 2. So 2r minus 5. R equals 23. So 2 times 23 minus 5. Remember, I have multiplication and subtraction, and order of operations tells me multiplication is first, so that gives me 46. 46 minus 5, which is 41. Number 6, the product of 4 and x increased by y. So product 4 and x is 4 times x increased by y. Okay, so this time we have two variables. So we have multiplication though and addition. In order of operations, it's multiplication first. So I'm going to say 4 times 9 plus 4. So 4 times 9 is 36 plus 4 is 40. V squared less than 42. Remember, less than is like a turnaround word. So we are going to switch these, okay? So 42 will actually go first. minus v squared. And so order of operations tells me that exponents come before subtraction. So when I rewrite this, I'm going to put 5 squared, and I get 42 minus, remember 5 squared is the same thing as 5 times 5, which is 25. Okay, and ooh, yeah, we gotta borrow, but you know what? I said you can use that calculator, so I'm gonna just do my 5. Whoop, 17. Okay, so that's it on that. And so just be mindful, your homework will be a lot like this. Here's some real world examples. We love these so much. So number 8 says Jack weighs 13 more pounds than his brother Andy. If A represents Andy's weight, write an expression to represent Jack's weight. Okay, so Jack weighs 13 more pounds than Andy. So Andy plus 13, okay, is going to be Jack. So now find Jack's weight if Andy weighs 78 pounds. So 78 plus 13 is going to be 91. Don't forget unit of measurement, pounds. Not too bad. Ebony is selling wreaths for a holiday fundraiser for $9 each. Write an expression to represent the total amount she will raise if she sells W wreaths. So each, when I'm saying each, I'm thinking about multiplication. So $9 for each wreath, like that, 9W, okay? And then, what's the total amount Ebony will raise if she sells 28? So 9 times 28, okay? Yes, I'm using my calculator. I don't blame you if you do too. Times 28. 252, what? Yep, dollars. Don't forget unit of measurement. Okay. Number 10. There are 4 students absent from Mrs. Mala's homeroom. Write an expression to represent the number of students present if there are S students on Mrs. Mala's homeroom. So 4 students are absent. So all of my students, but minus who's absent? 4. Okay. And then we know that there are, how many students are present? If there are 23 on her roster, so 23 is my students minus 4. We got 19 little studiantes in the class. Number 11, Carl ran 8 miles last Saturday as part of his marathon training plan. Write an expression to represent the average number of minutes that it took Carl to run each mile if he completed the run in M minutes. Okay, so here is the thing. When we see the word average, we're looking at division. So we have M minutes, okay, divided by 8 miles, okay? So if he completed the run in 72 minutes, let's find the average of miles, and 72 divided by 8, we want minutes, excuse me, is 9. So we're going to say the average was 9 minutes per mile. Okay. Number 12, 2/3 of the 6th graders are going on an upcoming field trip. Write an expression to represent the number of 6th graders attending the field trip if there are N students in 6th grade. So we know 2/3 are going, okay? So when I say 2/3 of is going to mean our multiply, 2/3 of the students. And then there are 291 students, 6th graders. So how many are going to go? So 2/3 times 291. Now we don't. That's not a 1/3. So we're going to have to do a little workity work in our calculator. Clear. You're going to put 2/3. Brighten that up a little bit so you can see that better. So parentheses 2 and 3 over, close parentheses, times 291. we get 194. So that means 194 students are going on the field trip. Okay. Number 13, write an expression. Wait, hang on. The sequel to a movie is 16 minutes longer than the first movie. Lord, when you're old like me, that's a long time. Write an expression to represent the number of minutes in the first movie if the sequel is m minutes long. So, this is longer. Oh. Okay. So, the sequel is 16 minutes longer than. That's a reversal. So we're going to take our first movie, M, minus the 16, okay? That first movie, the sequel is 112, and then minus 16 to get my original movie time. Because longer than, it's like more than, less than. We're reversing those parts of my expression. And I get 96 minutes. So 96 minutes. I can handle that. Last one. A group of 5 friends went out to dinner and evenly split the bill. Now, when we say split, we're thinking divide. Evenly, it's divided by how many people went? 5. Okay? Write an expression for the amount each person paid if D represents the dinner bill. So my dinner bill divided by 5. My dinner bill is $78.10 divided by 5 people. So we're going to put that, don't forget that decimal, it's very important. 78.10 divided by 5 gives me $15.62 per person. Okay, guys, this is easy peasy lemon squeezy when you take your time and use your notes and use your calculator too.